What if everything you see, touch, and feel isn't real? What if the very fabric of our existence is nothing more than a grand illusion, a sophisticated trick of the light? What if our universe, with all its vastness and complexity, is but a holographic projection, an image of reality rather than reality itself? Imagine for a moment that everything we perceive, from the smallest atom to the largest galaxy, is just a shadow of a deeper, more fundamental truth. This might sound like something out of a science fiction novel, but it's a question that physicists and cosmologists have been grappling with for decades. The idea that our reality could be an illusion has profound implications for our understanding of the universe and our place within it. At the heart of this mind-boggling concept lies the holographic principle, a theory that challenges our very understanding of the cosmos and our place within it. This principle suggests that the entire universe can be seen as a two-dimensional information structure painted on the cosmological horizon. The holographic principle suggests that our three-dimensional reality, with its height, width, and depth, might be an illusion. It posits that the true nature of the universe is encoded on a distant two-dimensional surface, and what we perceive as three-dimensional is merely a projection of this deeper reality. Instead, it proposes that all the information about our universe could be encoded on a distant, two-dimensional surface, much like a hologram. This means that everything we experience, from the flow of time to the solidity of matter, could be a complex interplay of information on this cosmic canvas. Imagine a security chip on your credit card, holding a vast amount of data in a seemingly two-dimensional form. This analogy helps us grasp how a two-dimensional surface can encode a wealth of information that manifests in three dimensions. The holographic principle suggests something similar might be happening with our entire universe. It invites us to rethink our understanding of reality, urging us to consider that what we see and experience might be just a projection of a deeper, more fundamental layer of existence. To understand the holographic principle, it helps to first understand the concept of a hologram itself. A hologram is not just a simple image, it's a complex, three-dimensional representation that captures the depth and details of an object. We're not talking about the Princess Leia kind here, though the principle is similar. In science fiction, holograms are often depicted as ethereal, floating images, but real holograms are created through precise scientific processes. A hologram is a three-dimensional image created by interfering beams of light that record information about an object's shape and appearance. This interference pattern is what allows the hologram to store such detailed information. What makes holograms so fascinating is that even a small fragment of the holographic plate can reconstruct the entire image, albeit with less detail. This means that each part of the hologram contains information about the whole object. This property of holograms, that information about the whole is contained in each part, is key to understanding the holographic principle. It suggests that every part of a system can reflect the entire system, a concept that has profound implications in physics. Just as a two-dimensional hologram can project a three-dimensional image, the principle suggests that the information about our three-dimensional universe might be encoded on a distant two-dimensional surface. This idea challenges our traditional understanding of space and dimensions, like the event horizon of a black hole. The event horizon is a boundary beyond which nothing can escape, and it's thought that all the information about what falls into a black hole is stored on this two-dimensional surface. The seeds of the holographic principle were sown in the 1970s, emerging from studies of black holes, those enigmatic cosmic objects with gravity so strong that nothing, not even light, can escape their grasp. Physicists wrestled with a paradox. If information is never truly lost, as quantum mechanics suggests, what happens to the information that falls into a black hole? Stephen Hawking, the renowned physicist, proposed that black holes actually emit radiation, now known as Hawking radiation, and eventually evaporate completely. However, this posed a problem. the radiation seemed random and didn't carry any information about the objects that had fallen in, seemingly violating the principles of quantum mechanics. This is where the holographic principle enters the picture, a concept that has revolutionized our understanding of the universe. In the mid-1990s, physicists Gerard T. Hooft and Leonard Susskind independently proposed a radical solution to the black hole information paradox, a problem that had puzzled scientists for decades. They suggested that the information swallowed by a black hole isn't lost, but rather encoded on its event horizon, the boundary beyond which there is no return. This was a groundbreaking idea that challenged conventional wisdom. This idea, though counterintuitive, offered an elegant solution to the paradox. It implied that the information wasn't destroyed but transformed and stored in a different way. The information wasn't lost, it was simply stored in a different form on a lower dimensional surface. This was akin to how a hologram encodes a three-dimensional image on a two-dimensional surface. This led to the broader concept of the holographic principle, that our entire universe could be a holographic projection of information encoded on a distant two-dimensional surface. This principle has profound implications for our understanding of space, time, and reality itself. Section 5. The universe as a hologram. Imagine our universe as a giant sphere. Now picture all the information about every star, every planet, every atom, and every subatomic particle encoded on the surface of this sphere. This surface acts like a cosmic movie screen, projecting the three-dimensional reality we perceive. This doesn't mean we are living in a simulation in the Matrix sense. There's no computer program or external programmer. Instead, the holographic principle suggests that our reality has a deeper, more fundamental level of description, one where information itself takes center stage. Section 6. Evidence and support. While the holographic principle remains a theory, it's not just a mind-bending thought experiment. There's a growing body of evidence supporting it, primarily from theoretical physics. String theory, a framework that attempts to unify all the fundamental forces of nature, has shown some intriguing connections to the holographic principle. Furthermore, studies of the cosmic microwave background radiation, the afterglow of the Big Bang, have hinted at a possible fuzziness in the fabric of space-time at the smallest scales, which aligns with the predictions of the holographic principle. Section 7. Implications for reality. If the holographic principle proves true, its implications for our understanding of reality are profound. It would mean that our everyday experience of a three-dimensional world is an illusion, a projection of information encoded elsewhere. Our very notions of space and time would be upended. Moreover, it would challenge our understanding of consciousness and the nature of the observer. If we are essentially holographic projections ourselves, what does it mean to perceive and interact with a holographic universe? Section 8. Ongoing debate and future research. Despite its elegance and explanatory power, the holographic principle remains a topic of intense debate and ongoing research. Physicists are working to develop more precise mathematical models and design experiments that could definitively prove or disprove the theory. One promising avenue of research involves studying the behavior of quantum entanglement, the strange phenomenon where two particles become linked and share the same fate, even when separated by vast distances. Understanding entanglement in the context of the holographic principle could unlock new insights into the nature of space, time, and reality itself. Section 9. Conclusion. A reality redefined. The holographic principle, though still in its theoretical infancy, has the potential to revolutionize our understanding of the cosmos. It suggests that our universe is far stranger and more mysterious than we ever imagined. While it may not provide all the answers, it offers a tantalizing glimpse into a reality that transcends our everyday experience. The quest to unravel the true nature of our universe is far from over, but the holographic principle stands as a testament to the power of human curiosity and our relentless pursuit of knowledge, pushing the boundaries of our understanding and challenging us to question the very fabric of reality.